When scientists create new substances, they have to submit them for elemental analysis to verify that they are what they think they are. And it's usually a blind type study where you send some random small amount of a powder, which I suppose sounds a little bit like illegal, to somewhere that analyzes it and they come back with the percent composition. If it's a match, you can publish your data. Let's do it for water. What is the percent composition by mass of water? The key is to understand that if you deal with a mole, it becomes easy. Can you see that 18 grams is a mole? 1 plus 16 plus 1. Can you see that the vast majority of it came from oxygen? Can you quantify that as 16/18? Well, if all that was logical to you, and I bet it is, you can see that water is 16/18 oxygen by mass, or 89% oxygen, and the rest is hydrogen. By the way, you don't have to do the 2/18 times 100 if you have the 89. You just do the rest, 11%. Empirical and molecular formulas are kind of the reverse. You have the percents, and there it is for some mystery substance, and you try to come up with a formula. Now, if you do it without any molecular mass data, you'll just get some ratio of carbon to hydrogen, right? It could be C1H1, for example. But there are plenty of substances which match that, but there are multiple of it. Benzene, for example, is C6H6. To go from empirical formula, which is the simplest ratio of elements, to molecular formula, which is the true ratio of elements, which is scaled, you need molecular mass to see if you got it or if you got to multiply it. This is a little less straightforward, perhaps, than percent composition, because you want a mole ratio, right? You want, like, H2O is a mole ratio of 1 to 2, right? 1 oxygen atom for every 2 hydrogen atoms, or scaled up, 1 mole of oxygen for every 2 moles of hydrogen. So if 12 grams is a mole of carbon, we have 86 grams. We have 7.1 moles of carbon. A little trick that I like to use to keep me on the right track is to put it down on the bottom. That's done. Of course, doesn't look very clean, but we come up with a quick method for turning that into a whole number in just a minute. 14 grams were hydrogen. Notice we're assuming 100 grams. That may not be obvious to you, but that's what you want to do, since if it's percent composition, they always add up to 100%. 14 grams of hydrogen, where 1 gram is a mole, is 14 moles of hydrogen. Let's do our little C14. Now that's done in a way. The answer is C7.1, and that should be a H. That is a typographical error. Please make that an H. C7.1, H14. There's always a little bit of wiggle room here, especially if you're using whole numbers like this. So this is fine to convert this into C1H2, and that is our empirical formula. Is it a match for the molecular mass? No, it's exactly half. 12 plus 2 is 14. Therefore, this substance actually is C2H4. And that's all you do, is scale it up until you match the molecular formula. And C2H4 could be, for example, ethylene. Okay, that's percent composition, empirical, and molecular formulas.